All right. So this introduces us to chapter 3, network basics for cloud computing. All right, let me clear the drawings. And forward, we are saying that the network consists of a variety of networking devices that we agree, isn't it? In addition to the traditional physical network, the networks of a virtualized environment also include invisible networks running inside servers. After some time, we are going to appreciate, and we actually come to realize what are these invisible networks that we are talking about that are running inside the servers. So this chapter will cover the basic knowledge about both types of networks. So we are saying here that upon completion of this course, you will be able to understand how physical and virtual switches work. We have physical and virtual switches, and also understand the network architecture used for virtualized environments, and also understand the traffic flows between virtual machines, and also understand concepts related to virtual LAN or VLAN. Okay, so let us look now at the network architecture for virtualization. Firstly, how do virtual machines communicate? Think about it. How do they really communicate? There are no cables inside. I have my host here. Okay. I have my host here. I've installed my hypervisor here. And this is my entire physical host. My entire physical host. Okay. I've installed my hypervisor there. And on top of that, I go ahead and I create my different virtual machines. So if maybe one is an application server and the other one is a database server and the other one is maybe a backup server, how are these devices going to communicate? Or let's say even I have another, let me use red. Let me say even I have another physical host somewhere. And I've gone ahead and I have still created my different virtual machines inside. Have my first virtual machine, my second virtual machine, and my third virtual machine in there. So how are these virtual machines going to be able to communicate? Let's say this is a database server, which I need to communicate and also be able to send and receive traffic from my server here. How do they really communicate? Who can guess? Because these are two different. This is machine A, this is machine B. How do they communicate? For those who have a basic concept in networking, and you know, for a device to be able to communicate, one, they must be on the same network. Two, or even if they're not on the same network, there must be some kind of gateway or a router somewhere or a switch that is going to help you send your packets from one destination, the source destination, to the destination. Okay, so we have already said. Who can guess? Is there someone who can guess? Or Tumusime, you want to guess?
Maybe using port numbers.
Maybe using port numbers. If they are using port numbers, will they be able to talk to this guy? We shall assume that
using internet.
We shall need a physical NIC here, and we shall need these computers either to be connected through a switch or router.
Right.
Not so. That is one.
Use either a switch or router.
But now inside here, how do these guys connect? Well, we know they don't have cables connecting them.
We use NAT.
We use NAT. Okay, good tries, but let's look at the chapter. We are going to be able.
They use NIC cards.
They use NIC cards.
Each virtual machine gets an NIC card.
Okay, each virtual machine gets a NIC card. So if our virtual machines, all of them get NIC cards, how are they going to? This one has a NIC card. This one has a NIC card. How do they communicate? Are there like virtual wires inside? Cables? or like virtual
No,
switches?
Samuel.
Yes,
I
please.
think
IP address.
they should be on the same network, so they
Mhm.
should share the same IP addresses at least.
But you know, if you have two machines with the same IP address, there is no
Yes.
communication which can happen. Actually, there is a conflict on the network.
Samuel, can I explain a bit?
I
Yes,
have a
yes, go ahead.
submission.
Yes, please.
I think the hypervisor provides the switch that actually connects the VMs.
Okay,
Yeah.
very important concept. The hypervisor provides some kind of virtual switch, isn't it?
Yes.
Which connects the virtual machines
VMs.
inside that host. Okay, that is a very important concept. Someone wanted to explain. You can go ahead. Was it Emmanuel?
Yes, I was going to say when a hypervisor is installed, first of all, we have the IP of the host machine. The host is going to have an IP. So then the rest of them, hypervisor, she says, provides a platform for these to be given IPs. So all these, as you're installing the hypervisor, it will either ask you to use a similar IP range with virtual machines or with a physical machine sharing an IP an IP range with a virtual machine, so it will allow the virtual machines create their own set of IPs. So after networking and setting up of maybe VLANs, or you want setting up of a normal switch to connect the PCs, they communicate.
Okay. Thank you for that explanation. So we have already said that in a typical network, okay, there are so many network devices that are used for us to be able to achieve traffic to flow from one point to the other point. So to enable hosts connected by two different switches to communicate with each other, the two switches must be connected using a network cable or an optic fiber, isn't it? So when it comes to cloud computing, many network devices are virtual entities running inside servers. These virtual devices communicate with each other, not directly through a network cable, but through entries in some logical forwarding table, which poses new challenges to network administrator. And that's why cloud computing is important. Also, this chapter is important to bring about or to help you understand some of the physical and virtual devices and how they are used in the virtualization or the virtualized environment. So we're having those different machines and we're asking ourselves, how do they communicate? And we have already said there's some kind of virtual entries inside the virtual machine. So let us look at briefly at the virtual. We are going to look at some of those devices. I know some of you could be in this class and you're not very familiar with some of the devices we're going to talk about, but we shall briefly go through some of them so that you understand. So we are saying in a cloud computing or in a virtualized environment, traffic is divided into two. We are having what we are calling north-south traffic and east-west traffic. Where in the traditional IT system, we do not really make such distinctions, okay? But here we make a distinction to demarcate and we say we have the north-south traffic and the east-west traffic. Generally, what you should take note here, that the router acts as a demarcation point distinguishing between north-south traffic from east-west traffic. So the router can be physical or it can be a virtual one. So the traffic, any traffic that passes through a router is what we are calling north-south traffic, while traffic that does not pass through the router is what we are referring to as east-west traffic. So if we have our internet data center, and we have maybe other data centers and we need to connect to them. Remember, we have our physical servers here, which are connected to the switch, they're also connected to our aggregate or core switch here. So we're having our router. somewhere there. So if there's any traffic that is going to come from these servers, and let me change my color to red, from these servers, and this traffic is going to go through our switch to our aggregate switch and then to the router, this traffic is what we are calling north-south traffic. And any kind of traffic, like let's say this is an application server and it wants to communicate with our database server, and the traffic is going just across our data center, but it is not traversing through the router, then we are referring to this as east-west traffic. Okay? So this is what we would call, like the way you have seen the illustration, what we are calling east-west traffic. And this is what we are calling north-south traffic, as long as it's traversing through the router. So don't be misled if you find an icon here. This is the router, and it is arranged like that, and maybe traffic is going through that router, or it is connected there, and we have our aggregation switch, and we have our different maybe switches connected to this aggregation switch. Okay? So don't be confused, since this is horizontal and they ask you which kind of traffic is this and you say it is east-west traffic. No, ideally it is not, as long as the traffic is traversing through the router, we are referring to it as north-south traffic. Okay? So let us try, yes, let us try and look at the different scenarios that are available. We have already mentioned and we already said that inside the server, we can have our virtual switches inside there. And the virtual switch is there, okay? The virtual switch is there and it is inside there. We have different kinds of scenarios. The first scenario is we have our virtual machine here, another virtual machine here. This is our physical, it's a physical server, A, B, C, and D. So one of the scenario is actually the virtual machine can connect directly to the network interface card of the physical server and connect to either the switch or whatever device is there after, without necessarily going through the virtual switch which is created inside our server through the help of the hypervisor. That is scenario one. Scenario two, that we can have a virtual machine having an interface card, also this one has an interface card, connecting to one of the ports on our virtual switch, and which virtual switch also connects to the NIC of our physical server, and then it connects to the entire network. Scenario three, we can have two virtual machines. Are you seeing them? This is virtual machine, another virtual machine. We can have two virtual machines, each having its NIC or network interface card connecting to the same virtual switch, which also connects to the entire network. So meaning we can have one virtual switch connecting either one or more virtual machines. Are we together? Scenario four, we can have one virtual machine connecting to one virtual switch, and one virtual machine also connecting to another virtual machine in the same physical server. Meaning we can have one or more virtual switches inside one physical server. Is that okay? So we're also having another scenario here where we can already see one of the scenario that we have two virtual machines. We have already seen the scenario connecting to the same virtual switch. We have already seen that scenario, isn't it? We have already seen that scenario.
Yes.
And we have already seen this scenario that one virtual machine can connect to another virtual machine, or we can have one or more virtual switches inside one physical server. And also we can have one virtual machine having two network interface cards connecting to two different virtual switches at the same time. Okay, as long as it has two, and I emphasize, as long as it has two network interface cards, and you can configure them on virtual machines. That's the beauty of virtualization. You can configure other more network interface cards on the virtual machine. And we're going to be looking into those details. But now let us look at some of the basic concepts of networking. Okay. All right, let us look at what we are calling a broadcast and a unicast. Okay. And we are saying that a broadcast and unicast are two types of network traffic. Of course, there's another one that is called multicast, but we are going to focus on broadcast and unicast. So when you hear the word broadcasts, we have some people who are good with networking here. What does that mean?
A broadcast is basically a packet that is sent out to all the machines on the same network, like in a group.
Thank you so much. It is a packet, ideally a broadcast you're sending to all the nodes or the machine on the network. Okay. Can you also tell us about the unicast?
Unicast would be sending to one node, to a particular node. Right.
Yes.
One.
So you're sending to a particular, actually to a particular node. Yes, you're sending to one node. Okay. It is one node sending to a particular node. Can you also tell us about multicast?
Multicast would be to a selected group of nodes.
Multiple.
Multiple.
Yeah, multiple.
Yes. Selected
Yes.
multiple
Group
nodes
of
on the
nodes,
network. Yes, that is very true. Could you also go ahead and tell us about the default gateway? Or anyone who wants to try.
The exit door of a network.
The exit door of the network. Okay.
For instance, if I have an IP address of 192.168.1.0, yeah, my next escape will be .1.
Yes.
And that usually is always assigned to the router.
Yes. So ideally, what our friend is telling us, that a default gateway is more like a default route, and it is usually the last choice for route forwarding. And this means that when no routing entry is available for forwarding the packet, then the packet will be sent through default gateway. Cynthia? Okay. To the default gateway. Someone can tell us, what is routing? What do you understand by routing? Yes, Paul, I see your hand is up.
Yeah, routing basically is just a route. A route through which most like devices that which you want to pass the information to are connected. Yeah, actually that is the passage. Yeah, I think.
Routing.
It's a pathway for network traffic.
A pathway for network traffic. How do I communicate? How do I send my packets from this virtual machine to that virtual machine? Okay. And what do you understand? What do you understand when it comes to VLAN?
VLAN comes comes to security part, where you're trying to restrict people of a certain maybe network access another network, kind of security kind of platform.
Okay.
Hello, check mic.
Yes, yes, Robert.
VLAN is
Go ahead.
also a virtual LAN, a virtual
Yes.
LAN network, or
Yes.
a virtual local network.
Yes.
Yeah.
Yes.
Like a network of the computers are represented in the virtual form.
Okay.
How about if I
VLAN.
say
VLAN is a local area network. Basically, it's a logical subnetwork that groups a collection of devices from different physical LANs.
Okay. What if it is from the same physical LAN? Can't you have a VLAN on the same physical LAN?
But if I say
Can I answer that?
Yes, you can go ahead.
A VLAN is basically a separation of it's giving rights to you have a network segment and want to divide it and give rights to each segment. So let's say you have Uganda, but you want to give every district its own rights, whereby Kampala can't access work in Jinja. So you divide them into VLANs.
Okay.
Let's take like your office, Ssendi. You have you have accounts, you have IT department, you have like advertising, but you don't want people in accounts to access what's in advertising. You don't want people who are in editorial to access what's in accounts. So you create those VLANs, yeah, to manage the security kind of bit.
Okay. So what you also understand, okay, those are very interesting ideas. Yeah, all ideas. Yeah. Like most of you have said, it is just a common way to subdivide a physical local area network. You are subdividing it logically. You actually get it and subdivide it, and you give it logical. You separate the logical broadcast domains. Okay, so this means that all the devices within the same virtual LAN can communicate with each other using MAC addresses, while those ones in the different LANs cannot communicate with each other. Okay, even if you are connected to the same physical devices, you're on the same physical network, but you're on a different VLAN. Okay, as long as you're on a different VLAN, you won't be able to communicate directly without passing through a layer 3 device, and you won't be able to send your packages to other devices on other virtual LANs. Okay, basically that is what VLAN is. So what do you understand by a router?
Can I say something?
Yes, you can say something.
I've heard people saying things to do with separating a network by using a VLAN. I also want to emphasize that VLAN can also be used to group different devices, even if they are on different physical networks. What do I mean by that? You might find two buildings have different switches, but those devices on those two buildings can communicate together so long as they are in the same VLAN.
Very true.
And another thing I heard about routing, I heard people saying it's a way of, is it packets, a path for their packets. I also want to emphasize that with routing being, because routing deals with IP, though VLANs deals with switching, which is Ethernet, the way I've said it, that one thing we should notice is that if you want to move packets from one network to another, you need routing. The same way you've said about a layer 3 device for the different VLANs to communicate with each other.
True.
So in simple terms, every time you see the word routing, there's a definition of packet forwarding, whereby you're moving from one network segment to another. You can't skip routing. But if you are in the same network segment, let me say you have one switch and everything is on 192.168.0.0 and it's a /24, then everything just switching. It's using that to communicate. So every time you're moving from one to another, that's when you need the routing.
True. Thank you for that. You can also go ahead and tell us what a router is.
Oh, I think my explanation now was specific to routing, but if you're just saying a router, it's a device. A router can be a layer 3 switch, or it can be itself a router. Sometimes those two things confuse people. I don't know why. The device is manufactured to be a router, and the device is manufactured as a layer 3 switch, which is also a routing device.
Okay, so for the purposes of thank you so much. Was that Pius?
This is Shamil.
It's Shamim, Shamiru. Okay, thank you so much for that submission. Now, as we are coming towards the end of this class, we have like about 7 minutes. People are talking about layers. In networking, basically, we have two reference models, which introduces us to the different layers in networking. We have one which is called I can't hear you. We have the OSI, reference model,
OSI.
the TCP,
IP.
Reference model. Now the OSI reference model has how many layers?
It has 7 layers.
5.
Are you sure?
7 layers.
You're saying 5?
Yes.
7.
Okay.
Yes.
It has 7 layers.
7. Yes.
Can we mention them?
Application layer.
Application.
Yes.
All people seem to need
Presentation.
data processing.
Presentation layer.
Application layer, presentation layer,
Session.
Transport layer.
Transport layer,
Yes.
network layer.
Network layer.
After session, there is transport. Transport.
Data link layer.
Network layer, then data link.
And then lastly, physical.
And the physical.
Please do not throw a pizza away.
Okay. And what happens in the application layer?
Application, that's when you have those softwares and
Actually, the interface.
Yeah, all things
Is the layer where the use
It's the interfacing layer.
Interface is created for the user applications.
Okay. What happens in the presentation?
It presents data.
Present data.
There is data that is divided into segments of frames.
Translates data for the application.
Okay, but very noisy background.
I think at presentation layer, it's where we have encryption and decryption of data.
Okay, but you know, really.
Ssendi.
Yes, please.
Ssendi.
Yes, please.
It's the way data is represented on the OSI model.
What happens in session?
It creates
session is immediately responsible for communication between computers.
Establishing, beginning, and
Today's class I separated the sheep from the goats. Today's class I separated the sheep from goats.
Okay, transport.
The transport layer manages the delivery and error checking of data packets.
Perfect. Network.
It's responsible for receiving the frames in data, or the frames of data.
From the data link layer.
receiving the frames from the data link layer. But here we don't deal. We deal with what? Packets.
With the packets.
Yeah, also I can add in network, we have the addressing and the path selection.
Yes, addressing, routing, or routing. So,
yes.
Data link layer.
For data link layer, it provides physical addressing and point-to-point services.
Perfect. Physical layer.
Where we have
transmitting over unstructured data. It's where we get the hardware, input, output, and other things.
For the physical layer, we have binary transmission.
All right. Okay, someone is saying today's class has separated the sheep from goats. What do you mean? Okay, so the physical. All right. So all right. So let us look at the physical layer. Which devices do we find here in the physical layer?
Repeaters, routers, hubs, switches.
No.
Cables.
Even modems on physical layer.
Okay, so
the cables.
Hold on. From physical, we have the cables, NIC, and hubs.
We have
keyboard.
Okay.
A repeater, a hub, the ones.
And the data link layer?
Switches, layer 2 devices.
Layer 2, you have to be very specific. Layer 2.
Physical layer, repeaters.
Devices.
Hubs.
Yes.
No.
Layer 2 switches. And a switch. A layer 3, and I emphasize for everyone who
hubs,
is calling
repeaters.
themselves either goat or sheep. For layer 3, which devices we have at layer 3? Layer 3 is network layer. Which device?
Routers.
Routers. Kindly take note of that. We
Layer
have
3 switches.
Okay. And the protocol here is
IP.
IPX. Now for the rest, you can go and read more about the reference models. They're not part of this training, but it is important that you get to know about those different protocols and the reference layers. So when it comes to TCP/IP, can we briefly, because we are out of time, it is time. It is actually
application.
We have application. Yes.
Transport.
Transport. Yes.
Transport.
Internet.
Internet.
And
network.
Network access. Network access.
Sometimes other people have 5 layers for this one.
Yeah.
Okay. So I kindly just go ahead and read more about the reference models, and also read more about virtual area network. Tomorrow we are going to start from virtual area network, and we're also going to try and understand this diagram here. Okay. And understand this diagram here. We are seeing different machines, different virtual machines on different virtual LANs, and we are seeing them being able to communicate. Okay, so thank you so much for being part of today's class. I appreciate each and every one of you. Thank you for the contributions, for making the class lively. Something I take
Mr. Ssendi.
for granted. Yes, please.
I have a question here. I don't know. Aren't we going to have the reading content on the site as well?
You want the slides?
The slides or anything.
The reading content has already been shared via Telegram channel. Did you enroll in the Telegram channel?
Yes, please.
Did you check the content I shared with you?
Maybe it was already shared. I'm going to check and see.
The channel has a few messages. This is the channel.
Okay.
This is a channel, and it has just a few messages from me. And these are all the content,
Okay.
and the reading material is here. Did you try to download and go through it?
Okay.
Yes, just download and go through it. Everything is there. That's why I keep referring you to it.
Okay, thank you very much.
Okay, even the slides are there, but even the notes are there. I shared everything already.
Okay, thank you.
All right.
Ssendi,
Yes, please.
just especially